Hi students, let us continue with the MCQs of pair of linear equations in two variables. Here is the first question. Two lines are given to be parallel. The equation of one of the lines is given by 4x plus 3y is equal to 14 and we have to find the second equation over here. Therefore, how we can find the answer? If you remember, we had already learned that if the equations are parallel or if the lines are parallel, how the condition is? The condition is a1 by a2 that should be equal to b1 by b2, but it is not equal to c1 by c2. So here we have to select the option in such a way that it matches with the condition here, right? So just observe here. What's the first option we have? We can just go with a trial and error method over here. So we have 4 in place of A1, 3 in place of B1 as well as 14 in place of C1. Now if you look at the first option, I have 3, 4 and 14. So when we look at A2 and B2 itself, we can say that A1 by A2 that is not equal to B1 by B2. Therefore, if we take this equation, it gives us the intersecting lines. Correct? So, we can eliminate this option. And if you go to the second option, just see here 4 and we have 8, that is 4 2s are 8, then 3 2s are 6, then 14 2s are 28. Therefore, the second option gives us a1 by a2 which is equal to b1 by b2 that is also equal to c1 by c2. This means it gives us the third option, that is coinciding lines, right? Now let us go to the third option here. What we have in the third option? We have 12, 9 and 42. So 4 3s are 12, 3 3s are 9 and 14 3s are 42. This also gives us the same previous answer, that is a1 by a2 which is equal to b1 by b2 that is equal to c1 by c2, that is coinciding lines. Therefore, option D should be the correct one. But let us just check it. Okay. So if we rewrite this equation, it becomes minus 12x minus 9y that is equal to 0. So when we write the ratio, it becomes 4 by minus 12 and 3 by minus 9. So this becomes 4 ones are 4 threes are 3 ones are 3 threes are. So the ratio is minus 1 by 3 that is equal to minus 1 by 3. Now the first condition is satisfied, that is first two ratios are equal. We have to look at C1 by C2. It should not be equal to these two ratios. Therefore, what is the last value, that is 14 here in the first equation and in the second equation it is 0. So any number by 0 gives us infinity does not equal to minus 1 by 3. Therefore, option D here is the correct option. That is minus 12x is equal to 9y. So, we'll move on to the next question. Here is the question. The point of intersection of the lines y is equal to 3x and x is equal to 3y is. So, if we have to find the point of intersection, that is this one. How we can get this one? To get this one, we should have the solution, that is x and y value should satisfy both of these equations. So what we can do, we can just go with a trial and error method over here. Observe what is given to us. So we have here in the first option, I have x as 3 and y as 0. I'll substitute this one in the first equation, y is equal to 3x. So here easy method is just go with the substitution of the values in any one of the equation. If it satisfies one equation, you can go with the second equation, or else just continue with the remaining options. Okay, so here I have x is equal to 3 and y is equal to 2. Sorry, y is equal to 0. So here 0, that is equal to 3 into 3. So this gives me 0 is not equal to 9. So we can eliminate the first option. Let us just check with the second option for the same equation. Okay, so here I have x as 0, y as 3. So 3 is equal to 3 into 0. This gives me 3 is not equal to 0. So even I can eliminate the second option because it is not getting satisfied with the first equation itself. Now I'll check with the third one. We have 3 that is equal to 3 into 3. So this implies 3 that is not equal to 9. Therefore, we can also eliminate the third option. Now, let us see the last option over here. We have 0, 0. So, y is equal to 3x, which is the first equation. Y is 0, that is equal to 3 into 0. This gives me 0 is equal to 0. So, this value is satisfying the first equation here. Let us check for the second equation. I have x is equal to 3y. So here x is equal to 0 and y is also is equal to 0. X is 0 is equal to 3 into 0. This gives me 0 is equal to 0. So what I can say, option D is the correct answer. We'll move on to the next question. Question is, if two lines are intersecting at a point that is only one point, then the equations will have how many number of solutions? So already we have studied that when we have intersecting lines, we'll have a unique solution. It means only one solution. When we have parallel lines, there is no solution, as well as when we have coinciding lines, we'll have infinitely many solutions. Therefore, here the answer is option A, only one solution, which is the direct question. So you can select the answer here. We'll move on to the next question. Here the question is, if the pair of equations 2x plus 3y minus 5 is equal to 0 and 4x plus ky minus 10 is equal to 0 has infinite number of solutions, then k should not be equal to or should be equal to which value? Okay, so to answer this question, what is the condition for infinite number of solutions? So for infinite number of solutions, the condition is a1 by a2 that is equal to b1 by b2, which is also equal to c1 by c2. So if we compare the coefficients of the given problem, we can write 2 by 4 that is equal to 3 by k, which is equal to minus 5 by minus 10. So this gives me the answer half. So observe here, they're asking to get the infinite number of solution, what we should have, right? Therefore, how we can go with this problem here? It is, we can directly eliminate the C and D option because they have given not equal. We just want to find the value of k, which is equal to what. So here observe that from the given option we can directly select the option B, that is k is equal to 6. Why? Because if you observe, the ratio is 1 by 2, here also 1 by 2, right? So for what value of k we can get the ratio b1 by b2 as 1 by 2? For the value k is equal to 6. Therefore, the option is B, k is equal to 6. We'll move on to the next question. Here is the question. If a pair of linear equations is consistent, then the lines represented by these equations will be. So they're asking whether they are parallel lines, coincident always, intersecting always, or intersecting or coincident. So to answer this question, just recall what we had discussed earlier. So we had discussed about this in the previous class. If we have intersecting lines, we can have only one solution, that is unique solution, and the system is consistent. Next, when we have parallel lines, there is no solution as well as the system is inconsistent. As well as when we have coinciding lines, we can have infinitely many solutions as well as the system is consistent. So if you observe, the system is consistent in two conditions, that is when we have intersecting lines as well as when we have coinciding lines. So if you observe the question here, they're asking pair of linear equations is consistent, then the lines represented by these equations will be. So we can eliminate the first option, parallel lines, because for parallel lines we can have inconsistent system, right? So in the remaining option, just observe that system is consistent when the lines are intersecting as well as when the lines are coinciding. So it is not just the coincident lines or it is not just the intersecting lines. Either the lines can intersect or it can coincide each other. At both the conditions we can have the system consistent. Therefore, the correct option here is option C, that is intersecting or coincident lines. Fine. So for today, I'm going to end the class. Keep watching, continue learning. We'll meet in the next class with a part 3 of the same chapter. So don't give up, study hard. We'll meet in the next class. Thank you.